Hi, welcome everyone. My name is Pınar Yılmaz, and I'm a principal software engineer and Amazon SageMaker team. And I'm joined today by Jeff Boudier, product director at Hugging Face. I'm very excited today to talk about Amazon SageMaker training compiler and its application for deep learning model training. So let's briefly take a look at our agenda today. We'll begin by discussing some of the challenges with training state-of-the-art deep learning models. Then we will introduce SageMaker training compiler and discuss some of the benefits. We will then hear from our special guest from Hugging Face to discuss how training compiler can help our customers. And finally, we'll wrap it up with a demo of the training compiler and some Q&A. So today, advancements in deep learning have led to increases in the size of the models and training data. For example, Roberta, a large NLP transformer model, has a training data set of 160 gigabytes in size. Other large models, such as GPT, can have hundreds of billions of parameters, and we're even starting to see experimentation with models that have 1 trillion or more parameters. With these large models and training data sets come two very general challenges that customers face. First is long training times, which stymie iteration and absorb developer time. And second is high training costs, which can preclude companies from experimenting with new technologies. Some things customers can do today to speed up training include scaling up or scaling out their machine learning workflows. For example, on SageMaker, customers can access cutting-edge GPU instances for faster training. Additionally, customers can move to a distributed system with data or model parallelism and scale their deep learning models across a cluster of instances. However, while these methods reduce training time, they may not reduce costs, because moving to a larger or more instances can be more expensive. Further, the skill and time required to move to a distributed training system can be formidable. Alternatively, customers can turn to compilation. Optimization with smarter compilation could be a win-win approach with respect to these two challenges, training time and cost. Optimized compilers for deep learning models promise efficiency gains, and you can achieve faster training speeds without changing hardware or expanding your cluster or incurring greater cost. Compilers, speaking generally, lower code that a developer creates from a high-level representation down to instructions that the hardware can understand and execute. Compilers that are optimized for a specific use case and architecture can grant material performance gains. In fact, we've already seen optimized compilers make a difference in machine learning today. With services like SageMaker Neo, which is an inference compiler, customers can increase inference speed by up to 25 times. Hundreds of millions of Alexa devices take advantage of this inference compilation technology to deliver faster machine learning powered answers for customers today. However, the solutions for training compilation that exist today are challenging for customers to adopt. Let's take a closer look at what customers can do today. So there are three general approaches that customers can take with respect to deep learning training compilation. One approach is using the standard compilers built into the frameworks like PyTorch and TensorFlow. This is where a lot of customers are today, because it's the default approach and there's no incremental implementation. The problem is that the default isn't very well optimized. For example, the default framework does not make any computational graph level optimizations. So customers end up leaving a lot of performance on the table when they stick with the default settings. Here, the training process does not take full advantage of the hardware. In the absence of a good default, some customers have chosen to develop custom hand-coded compilers tailored for their specific use cases. While this can bring performance improvements, it's impractical for most companies. The skill set required to develop a training compiler for deep learning requires both robust system engineering skills and machine learning engineering skills, which are in short supply. Additionally, getting to a basic initial working solution can take months or even longer, and the result will likely be a bespoke narrow solution. Customers can choose to use third-party compilers and open source tool chains. These can improve performance and abstract away some of the underlying complexity associated with compilation. However, implementing this is still not easy. It requires customers to leave their normal machine learning workflow to experiment with the compiler, go through trial and error to find the best settings before they can really unlock any speedups. Support is also limited. And especially for PyTorch users, there is no production quality compiler solution today for training on GPUs, so not so ideal options. So we're excited to announce that we have released SageMaker Training Compiler, which solves this difficult problem. SageMaker Training Compiler aims to be the easy-to-use compiler solution that also provides state-of-the-art performance, bridging the gap for customers. Let's talk more specifically about some of the benefits. SageMaker Training Compiler offers these hard-to-implement optimizations that can accelerate machine learning training. In our tests, we've achieved speedups of up to 50% relative to benchmarks for popular NLP models such as Roberta and GPT-2. Training Compiler is integrated with the versions of PyTorch and TensorFlow on SageMaker so that implementation can be completed in a matter of minutes. For most jobs, Training Compiler requires fewer than 3 lines of code to enable optimizations. So it keeps it simple, and customers can focus on their normal machine learning workflows. Finally, Training Compiler is free to use as a new capability of Amazon SageMaker. The speed-up benefits that Training Compiler offers result in direct customer savings with no extra premiums or fees for its use. So let's have a look at this chart. This chart provides some insight into how SageMaker Training Compiler works with a model training job. Here, we're comparing 2 PyTorch training jobs, one optimized with Training Compiler and another without these optimizations. You can see that with Training Compiler, there's some initial overhead at the start of the job as optimizations are made. In our short 1 epoch training job, the first set of bars on the left, this overhead increases the total training time. But thereafter, each subsequent training epoch is accelerated. As training progresses, Training Compiler outperforms the default framework. For jobs that are sufficiently long enough, the accelerated training process eventually makes up and then overcomes the initial compilation overhead, shortening the total training time for your model training. Compilation takes just a few minutes for most models, and some speedup can be achieved even for training jobs that are just 30 to 40 minutes in length. The Training Compiler is designed to fit into your existing SageMaker workflows, so our customers can focus on their core mission of converting data to insight. Customers start by enabling Training Compiler in their existing SageMaker training script. Minimal code changes that can be made in minutes is all that's required, and detailed documentation outlines how to make these adjustments. You'll see some sample code in just a few minutes. After that, the rest of the workflow is unchanged. You launch the job, the Training Compiler goes to work, implementing the optimizations to make more efficient use of the hardware. And beyond the simple changes to the training scripts, the rest of the experience is unchanged. The output from the training process is the same trained model in S3 that's ready to deploy with no additional changes. Under the hood, SageMaker Training Compiler accelerates training by converting deep learning models from their high-level language representation to hardware-optimized instructions to outperform the native framework. More specifically, Training Compiler uses graph-level optimizations such as operator fusion, memory planning, and algebraic simplification, data flow level optimizations such as layout transformation and common sub-expression elimination, and backend optimizations such as memory latency hiding and loop-oriented optimizations. And this produces an optimized model that efficiently uses hardware resources. As a result of these optimizations, compiled models train faster. So to implement the training compiler and unlock the speed up benefits, customers training on SageMaker simply includes a new compiler config class in their training job script in SageMaker Studio notebooks or in the CLI or the AWS SDK directly. And I should also mention the batch size here. SageMaker training compilers optimizations can decrease the memory footprint of the model training process. As a result, we can typically fit a larger batch size in memory, and this larger batch size allows to even further speed up the training when using training compiler. To demonstrate the benefits of SageMaker training compiler, I'm excited to share some of our benchmarking results. Here we compared the total training time for a job using SageMaker training compiler against the same job without training compiler. This test was conducted on a variety of different NLP models from the Hugging Face Transformers library, and we highlight a subset of the most popular models in this slide. So you can see we're getting more than 50% decrease in total training time when training compiler is enabled. I'm also happy to highlight that because training compiler is free to use on SageMaker, and because with AWS you only pay for the resources that you use, this decrease in training time directly results in cost reduction. We've partnered with Hugging Face to optimize training for some of the most popular NLP models available through Hugging Face Transformers library. These include models from the BERT and GPT family, such as Roberta, Albert, and GPT-2. And now customers can fine-tune these models on SageMaker to accelerate their training jobs with training compiler while also lowering the costs. Let's look at some of our customers who are using SageMaker training compiler today. Guidewire Software is a digital analytics and AI cloud platform provider for more than 450 insurance companies worldwide. Guidewire uses SageMaker training compiler to accelerate their customer NLP workloads for industry-specific applications such as risk assessment and claim operations. They expect training compiler to reduce training time and costs for these jobs by more than 20%, and that's a real win for Guidewire and its customers. Musixmatch is a leading music data company providing data, tools, and services that enrich the way we experience music by enabling features such as searching for songs and sharing song lyrics. And Musixmatch uses Amazon SageMaker to build natural language processing and audio processing models. They're excited about how easily SageMaker training compiler fits into their existing workflow and for its speed-up benefits. Because SageMaker training compiler's compatibility with Hugging Face, Musixmatch can seamlessly enable compilation in its existing environment and is able to reduce iteration time on a new model from weeks to days. Quantum Health is using training compiler to enable experimentation with new models and larger data sets. Quantum Health uses NLP for text summarization and classification to help its members navigate their healthcare decisions in a smarter, simpler, and more cost-effective way. NLP is a rapidly developing area of research. SageMaker training compiler helps Quantum Health to experiment with new models faster by reducing training time and cost overhead, making them more agile and innovative. And now, I would like to invite our special guest to the stage, Jeff Boudier, Director of Product at Hugging Face. Welcome, Jeff.
Thank you so much, Pinar. And yeah, thanks for inviting me to tell our experience with the SageMaker training compiler. It's been really great to have the opportunity to have hands-on with it prior to its release, and so I'm happy to share our experience with you. And maybe if there's like one thing that I want you guys to take away from this is that if you're already using Hugging Face in SageMaker with the Hugging Face deep learning container, then basically the training compiler works out of the box, right? It's a one line change, one parameter to add to your estimator, and it works out of the box. You get faster training. So that's pretty cool. And yeah, before I get into it, I want to give you a little bit of context. Maybe you don't know too much about Hugging Face. You know our open source, but less about our company. So that's our logo. And I'm happy to give you a little bit more context. Our mission at Hugging Face is to democratize good machine learning. And for us, the most important thing that happened over the last 3 years in the world of machine learning is transfer learning. That is the ability to leverage huge pre-trained models that have been trained on massive amounts of data to efficiently adapt them to your business problems through transfer learning. And what that does is that it creates an opportunity to build the future of machine learning in a more collaborative way. That's why our approach at Hugging Face to democratize good machine learning is around those 3 pillars. It's to do everything in the open, is to do everything in a community-driven way, and to do everything in an ethics-first way. We know all about the limitations and problems that can arise from large language models. The solutions are yet to be built. That's why doing everything in the open with the community is the best way to tackle that. The end result of all this work is that we're accelerating the time it takes for the latest science to make it into production at your companies, right? From the time that this cool new paper comes out and the time that you can use it in your workflows and in SageMaker, we make that as short as possible. So what I'm trying to picture here, and it's not easy because there are lots of pieces to it, is what is the Hugging Face ecosystem, right? We want to make state-of-the-art machine learning accessible. So a huge part of it, and maybe the one you're the most familiar with, is our open source. So with the Transformers open source library, the datasets library, and the tokenizers library, you have a complete workflow to do transfer learning on your own data. It represents the work of our teams. We're about 100 people today, but really it is the expression of the contribution from over 1,000 open source contributors whom we are very grateful for. It is, I think, Transformers, the fastest growing in terms of adoption open source projects, I think, ever, with 55,000 GitHub stars for our main library, the Transformers library, which was introduced just 3 years ago. And if you take the ecosystem together with datasets and tokenizers, that's 70,000 GitHub stars. And of course, we started from NLP. That's our root. In fact, the Transformers library was originally named PyTorch BERT. But today, really, Transformers are producing state-of-the-art results, meaning like more accurate predictions in all modalities. And that's certainly true with speech, but that's also true with vision today. So that's our open source. And then on top of our open source, there is what we call the hub or the platform. It's what you see when you go to our website on huggingface.co, where you can have free access to over 20,000 public transformer models that have been pre-trained or fine-tuned to do any of the tasks within the NLP realm or any sort of speech or vision task. They've been pre-trained or fine-tuned in over 200 languages, so whichever language your customers speak, you will find a model that is ready to use for that. You can find over 1,600 free and public datasets. Again, like the link between datasets and models is really important and critical to create this open ecosystem. In addition to our own libraries, the Hugging Face Hub is also the opportunity to explore and access models from our partners' libraries. So you will find scikit-learn models in there, you will find Allen NLP, you will find speech-brain models in there, TIM models for vision, etc. What you can do with all those models and all those data sets is do further fine-tuning or training with AutoNLP, serving predictions with the Inference API, demoing these models into simple applications with our new Spaces product, and then deploy them for scalable production with Infinity. Everything you can do with our open source, with all those models and data sets, you can do within SageMaker. And we've been very happy to have a close collaboration with the SageMaker team to provide you with easy-to-use tools so that you can pick up the Hugging Face deep learning container and then pick up the estimator, the Hugging Face estimator within the Python SDK. You can pick up the Hugging Face inference toolkit within SageMaker and have a ready-to-use solution to leverage all those models and data sets. And ready-to-use solutions that are also taking advantage from amazing features of the SageMaker platform, like data parallelism, model parallelism, and today, the SageMaker training compiler. All right, so what does it mean in practice? Well, this is the Model Hub homepage. So you can see we have over 20,000 models available. You can easily filter them by the task, whether it's text generation, summarization, translation, generating text, transcribing speech, detecting objects in images, in videos. You can very easily narrow it down to the language, the framework, the library, the task that you are targeting. And what do people do with it? When we have over 10,000 organization companies that today use transformers within their workflow, some popular use cases are to automate customer support. So you have a customer coming to you with a request, and you want your models to understand what is the sentiment, what is the topic, where should this go, is this important? Another very important use case is semantic search, so that you can return results to your customers that semantically make sense. So if I put search for blue dress shirts for men, if I'm using a keyword-based search, I will get some dresses and I will get some shirts with semantic search. The model understands that you are interested in men wear, it's also very useful for use cases of UGC moderation. Roblox has a great blog out there showing how they scaled up Distillbird to produce over 1 billion transactions, 1 billion predictions, every day. The models are used today at high scale to do things like translation, to do things like summarization, or to transcribe what I'm saying, probably, into text. Cool. Some wisdom from some of our users and customers. Profia is an innovative real estate company based out of San Francisco, and they tell us how using Hugging Face with SageMaker makes their life easier. Hugging Face allows for that one-stop shop for Profia, where we can grab pre-trained models from the hub, fine-tune, and then deploy them on SageMaker. And similarly with Customer, Customer is a customer support service that you can use to better serve your customers. And they say Hugging Face makes transformers, which are traditionally hard to use, easy. So that's about Hugging Face, and that's about how we integrate Hugging Face within SageMaker. But the reason I'm very excited about the SageMaker training compiler is because scaling training of models is a really hard engineering problem. And from the initial BERT model with like the 340 million parameters of its large version to now models that regularly go over 1 billion parameters, like that process of scaling is actually non-trivial at all. We know this from our customers, but we also know this ourselves. As through the Big Science Workshop, part of our team is attempting to scale large language modeling today with the first model, T0PP, at 11 billion parameters. If you're interested about the engineering challenges of scaling large language modeling, then I really encourage you to look at the work of the Big Science Workshop. They're documenting everything they do out in the open, so there are lots of great lessons there. So models are getting bigger. Scaling training is complicated. The data sets that are used are also getting bigger and bigger. So for instance, with the Big Science Workshop again, we leveraged the Pile, which is 800 gigabit of data. And that means that these training jobs result in millions of hours of GPU. And so being able to save 20, 30, 50% of that is a big deal. The training compiler, as Pinar explained, will first compile your model and then start your training job. It will enable the memory footprint within your GPUs to be reduced so that you can do larger batch sizes and have a faster training at the end. So that's why we found that with the SageMaker training compiler, we're able to test similar models from BERT to DistilBERT to Roberta and now GPT-2 to really increase the batch size and reduce the training time by up to 40% in our initial testing. And what we've observed is that the longer the training job you have, then the more you will benefit from the SageMaker training compiler. What seems to be, for us, the sweet spot is the 30-minute mark. So if you're pre-training a model, of course, you will go way over that, and you're going to get a lot of benefit from the training compiler, the SageMaker training compiler. But for some fine-tuning jobs also, you will need to train on a large number of epochs, and you will easily go over that threshold and benefit from the SageMaker training compiler. Another thing that we've observed is that there is a bit of a trial and error to find the right batch size that will give you the most benefits. So depending on the model you're using, depending on your training script, I encourage you to always sort of test the limits of how much you can increase the batch size for your training so you get the most benefits out of the SageMaker training compiler. All right, so to sum it up, within SageMaker, you have access to an amazing platform to do work with Hugging Face, right? There is the Hugging Face deep learning container that abstracts away for you all the complexity of which libraries and which dependencies should you use for which version of PyTorch, etc. Everything is ready to use for you. And in addition to the deep learning container, you have access to the custom estimator within the Python SDK. You have access to a Hugging Face inference toolkit to deploy your models easily. And now, with the SageMaker training compiler, all your training code that you already have works natively out of the box with a training compiler. And you get the benefit of the acceleration. All it takes is adding that parameter to the estimator that Pinar described earlier, and you're good to go. So overall, that means that with the deep learning container, with the SageMaker training compiler, with the inference toolkit, with the custom estimator, you really have like the best possible environment within SageMaker for you to work with a Hugging Face model and scale those trainings and scale those model deployments for our models. All right, so now I want to hand it back to Pinar for a demo.
Thank you so much, Jeff.
Thank you.
All right, so let's switch over to the demo. So what you see here on the screen now is my studio working environment, and I have a bunch of notebooks there. And these notebooks are now available in our Amazon SageMaker examples repository on GitHub. So you're welcome to check them out and try them out yourself. So what I'm going to show you today is how to run training jobs with Hugging Face and SageMaker training compiler. So what we're going to do first is, in this notebook, first I'm installing a bunch of required packages. So I'll quickly scroll through those and show you how we set up the training job. So the initial steps are basically downloading the data set, tokenization, getting ready for training. And here's so far everything is boilerplate. And this is how we would set up a training job using Hugging Face estimator in SageMaker Python SDK. So in here, basically what we're doing first is creating a Hugging Face estimator. and we're providing our own training script. And we're going to be fine-tuning Roberta base model today, and we're going to use the SST2 data set, which is a movie review data set. And we want to be able to predict if the movie review is a positive or a negative sentiment. So we're going to fine-tune this model for 10 epochs. And this is how I would run this training job today. So far, everything is like pretty standard. And all I have to do to kick off this training job on SageMaker is to execute this cell. So I'm going to do that just now. And here, I see the training job that I just kicked off. Now I want to do the same exact thing, but with training compiler. So what I'm going to do is I'm going to add a new cell. I'm going to copy this exact same code over, and I'm going to import training compiler config class from SageMaker Python SDK, and I'm going to add it to my Hugging Face estimator. That's it. So I want to draw your attention to a couple of things here. So first off, like we've been discussing so far, I'm able to fit larger batch sizes. So I'm going to bump up the batch size, and I know that 24 works. Even if I don't do that, I am going to get speed up benefits. But with this, I'm able to exploit more and more of my hardware resources and utilize them as much as I can. And the other part is, we have disabled SageMaker debugger here. And we have done the same thing for the native job as well, just to be able to compare apples to apples. And this way, I won't be missing out on any performance gains. And all I now have to do is execute the same cell. So you'll notice that I'm getting another training job ID here, and this time it's training compiler enabled. So if I go back to SageMaker console and refresh this, I can see that my jobs have kicked off and started. So this job, even though it's only for 10 epochs, is going to take close to 3 hours to run. And with training compiler, we would expect that will be lesser than that. And I've actually done this before, so I'm going to switch over to my previous results and show you what that looks like. So in the rest of the notebook, here we're going to be downloading the training job logs and analyze them and see how much speed up we have achieved. So I'm just parsing the logs here to look at what my throughput is. I'm looking for training logs that describe the samples at each step. And if I plot them like so, I can see that my throughput in terms of the samples per second has improved when I'm using training compiler. And in here, for example, with the native framework, I'm able to get about 65 samples per second. With training compiler, I can achieve up to something like 90 samples per second. And that results in 42% improvement in throughput. But how does that translate to billable time? Basically, the total duration of the training job. So let's have a look at that. But first, I want to show you the loss analysis here. So yeah, I'm training faster, but am I getting the same functional and accurate model? So we compared the loss values throughout the training here at each epoch, and as you can see, they're pretty close to each other. So even though I'm training faster, I'm not giving up on any accuracy or functional properties of my training or my resulting model. So again, let's have a look at the billable time. So if we look at the total duration of the training job, which is what I'm actually going to be paying for, is with native training, I'm going to be using about almost 3 hours. And with training completion, that is a little more than 2 hours. So I am saving 49 minutes here, and that corresponds to a 20% improvement on the total amount of the training time duration. So just for 2 lines of change, that's pretty sweet. So yeah, so in our public documentation, you can see some of the tested instances and also the batch sizes that you might want to start with. So we have been publishing these to make it easier for you to get started. And this is our developer guide for SageMaker. You can find a training compiler there. And also you can look at the example notebooks, and you can see the example notebooks here that I was just showing you earlier. And all of this is generally available today. So with that, let's get back to our presentation. So now that we have seen the demo, I'd like to wrap up with a few points to leave you with. So to recap, our customers can enable SageMaker Training Compiler on their PyTorch and TensorFlow models to unlock training speedups of up to 50%. Training Compiler is free to use for SageMaker customers, and in fact, customers can use Training Compiler to lower their bills as they are able to train in less time. Finally, I'm excited to announce that SageMaker Training Compiler is generally available starting today. So these are some of the links that I was showing you earlier. I would like to encourage you to have a look and start your own experimentations. And you can learn more about the other features and advantages of training with SageMaker in addition to the training compiler on our website. So if you have any other questions or feedbacks, feel free to reach out to us. We'll be happy to hear back from you. And now that we have about some time remaining on our session, we'd like to open up some questions that you might have. Go ahead. Sorry, could you repeat the last part? Other? I'm sorry, I'm going to walk close to you because I'm not able to hear. Oh, right. Okay, got it. Okay, sure. So the question is the availability zones and regions where SageMaker Training Compiler is available. So we are available on 4 regions, and those are US East 1, US East 2, EU West 1, and I'm forgetting the last one, and US West 2, I believe. That is available in our documentation. So 4 regions and more to come later. Thank you. Any other questions? So we have tested a bunch of models, which are one of the most popular ones. As you can tell from Jeff's presentation, there's over 20,000 models available on Hugging Face. And we've been able to test the most popular ones. And we have published those list of models and the batch sizes and other settings that we've tried on our public documentation. So you're welcome to try any other model. Even though it may not be part of the list, that doesn't mean that SageMaker Training Compiler is not going to work. If you encounter any issues or you're not seeing enough gains, we have some troubleshooting and best practices tips on our documentation as well. And we're happy to hear from you and help you out on your journey if you need more assistance. Sure. Let me repeat the question. The question is, if it's that easy, why is it not the default? Well, in the future, it might very well be. This is just the beginning of our journey with Training Compiler. That's a good feedback, and we would love to see Training Compiler enabled everywhere all the time pretty soon, hopefully. The next question is, have you seen cases where there were diminishing returns? So the performance gains are actually somewhat model dependent, and it also depends on how the training script is set up. So there are a few cases where certain patterns in the programming, for example, logging of intermediate values will hurt the performance. So it's really on a case-by-case basis, and it varies from model to model. But there are a few things that you can watch out for to make sure that you don't lose out. And again, I'd like to refer you to the best practices and tips and troubleshooting that you can look up on our documentation. So the next question is, why is it only NLP? Why no computer vision models? So to echo the sentiment from the previous question, we would ideally like to see Training Compiler enabled for all the models, all the time, everywhere. So for our initial launch, we've been focusing on the large language models because we find that there is a lot of pain and challenges there that we could immediately address. But we would like to see the Training Compiler for all kinds of models in the pretty soon near future. All right, I don't see any other questions. Oh, one more here. So the Training Compiler is available for deep learning frameworks. At our initial launch, we support PyTorch and TensorFlow. If you have any other frameworks of interest, I'd like to talk to you and find out more about what those are. And maybe we can talk more about those and see how we can address some of those use cases as well. Okay, sure. All right, thank you. All right, thank you so much for coming here. I hope you enjoyed the session. Please fill out the survey, and I would love to hear more from you if you get a chance to try it out and let us know how you find. Thank you.